cylinder with water in it, and it has a lead plate in front. So first here, as you can see, it does not show the lead plate in front, because apparently this this part, so it is, as we know, it is like 2D, but it only shows you the cross section. So at the origin 0, 0, 0, it cuts the object, and it shows it to you from the cut, not the entire object. So that's why we don't see the lead plate here. The lead plate is supposed to be here.
Yeah.
Vishal, are you fine?
Yeah, I'm following.
So I will just show you a 3D view of it. Just a second. Where is the plate? Oh, damn. Where is the plate? Okay, it is not showing now. Wonder why. Okay, so here you can see that there is a plate too. So 1, 2, and when I get close, so it's here. This one is 3. So this is the plate in front. So what I did, maybe you guys can change this part a little bit. So RCC, it's a rectangular cylinder. So it's 0, minus 60, 60. So these are just the dimensions. This is X, Y, Z. Then you have, this is the base. The base of the cylinder at minus 60 Y. Let me just show you like this. So here, this is minus 60, this part here. Just a second, I will just annotate. So yeah, this is this one here. It is at minus 60. And you have also like the lead, the stainless, it's a stainless steel cylinder. So it has a thickness. So this one here is the other cylinder with a thickness.
Yep.
Okay.
And this is the height of the cylinder. So 120. So this is the height. And so the radius. So it's pretty simple, like we did before. I was having problems with the box command. So what I did, I just made 6 planes. So these are the planes. I looked at the data. So I looked at the data, like how long should the plate be? So this plate, how long, how wide, and how thick. Here is how thick it is. It shows it. Yeah. So it's 1 centimeter thick. So that is the data. And this is the limits of the world. I just did this. It's not really important. As you can see here, I guess, yeah. So this is the limits of the world. And then it has been brought to my attention from AJ and Tuche that we do not need neutrons here. We only need protons. So if you are taking notes, Vishal,
Yeah.
This should not be here. And I also proved this to myself because there is, when I ran this file, it ran. It's fine now. It is working. It does not show the neutrons. So it shows the neutrons, but it's 0 all around. And then we have photons, which are nuclide is so it was cesium, right? Cesium 137.
Yep.
Yeah, so it releases photons. I checked the decay scheme, and in the decay scheme, I found the stuff. So the stuff is here. Just a second, let me clear this.
So when we don't have a neutron flux, do we even need the command for the library?
So I am not sure about that, but she said, like, it's really, I was reading about the libraries, and it's so complicated. Like they have, for example, iron. They have a library for iron. They have 7 different libraries. And the
Yeah.
way you achieve those libraries is by writing, for example, here. So what I found out is that if you want a certain library, you write here 60C, for example. So you go to the access. So what I did, you don't usually go. You're supposed to know this. I think the professor
Yeah.
should tell you this, but whatever. So I went
Yeah.
here, and then I looked for So this directory.
Yeah, I looked into that, but I couldn't, wasn't able to look which one of this I have to fetch.
Yeah, so this is the ENDF60 data. So this data, ENDF60, it tells you something about the system. Like it tells you is it about temperature, or is it about, like, it has different stuff. And there you have, after F60 you have EURESA, then you have F6DN, then you have RMCCS, and all these, they mean different things. So for example, if you were supposed to define hydrogen, let's say you have hydrogen gas somewhere, and it is, let's say this means 500 degrees Kelvin, you use 0.60 C, and then it takes the data according to this, how can I say, to this directory, so to the ENDF60 directory. And if you have hydrogen, let's say 1000 degree, I'm not sure, I'm just using it as an example, then you use this one. So 50C, you write 50C in the end, which is RMCCS. And then for neutron only, it is like LWTR. So all of these are different directories. You see, ENDF, TRM, CCS, all of these mean something different. Which is a pain in the ass if you want to work with this. Like, I don't know why people would do it. You can
Maybe
just
because there's somehow one preferred library that you're told that you have to use with, and then you can easily look it up.
yeah, exactly. As I've seen, they are also used for comparison of the data, but I still do not get why wouldn't they be the same? Like, why wouldn't they use the same directories? I still don't understand that clearly. I have to read more. There are a lot of good stuff, by the way. So MCPlib02. There are a lot of good stuff in the extras of the file. So it was, I think, somewhere on this. Yeah. So here, there is a lot of good stuff that explains everything. So yeah, M1, so it's showing this, and it's just expectations to use elemental photoatomic tables. So yeah, you just use this. You don't need to use 0.02 or 0.01E. So this shows why would you use 0.02 or 0.24C. So, yeah. Then I found out, or am I left? So you understood what I meant by that, right? So you just add here 20C or 24C, whatever. It depends on what it wants from
But
you.
we don't really need it because we're not using a neutron flux.
Exactly. We're not using the neutron flux. We will not need, but we need the photon stuff. So maybe for the photon stuff, we need something. I'm not sure about that. I'm gonna have to further discuss with AJ and Tuchek.
Okay. Can we then delete the neutron flux from the telecard?
The neutron flux is gonna have to be deleted. Similarly, these tables that I wrote, that it took me like 30 minutes to write all these numbers.
Yeah, because you have to type it up and couldn't just copy it from her presentation.
Exactly, I had to copy all of it up. So what this table is now, it's unnecessary. And what am I gonna do is just use this table. So you write the energies, and then you write the DFs, right? So you go like the 0.01, blah, 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 and you write DFs, and you go, and so this one is also, is it? Yeah, this one could also be the photon flux to those, even though it doesn't have a name. I guess it is. Let me check a number. 0.15. No, 0.2. Actually, it's no. Okay, I guess we have to write all of this. 0.1. So it's a different table, and I don't know what does it mean. What?
So these are just two different kinds of measurements, I think.
Yeah, it could be. It could
It's
be.
one because the left one is from INSI and the right one is from ICRP21.
Oh yeah, it could be. But this here, okay, yeah, you're right. Yeah, you're right. So you write only one of them, as she did here. So basically what you do, you check this one, DE15, then you go here and you check what's written to neutron to flux to dose rate, blah, blah. You check what she wrote and how she wrote the numbers, and then you just write the same thing here. So DE, DF, you write here photon flux to dose rate, and that's it. And this is pretty much it. So also here, so you write F15 for the, or F5 for the gamma flux, and then you write F15 for the dose rate, and you write the point. So this is X. Okay, let me just write this. So this here, it's supposed to be X, Y, Z, and then it's the radius. So how far, so this is our tank. So let's say these are all 0, 0, 0, 0, 0. This is the middle of our tank. And then the radius, it's how far is the point detector, right?
Mm-hmm.
From our tank. So she gave it, I think, let me check. She gave the spaces. Yeah, the height of the detectors is 81 centimeters at the same height as the source. So we defined the source. Where did we define this? Yeah, so the source is at 0.210, which means 81 above the base of the cylinder. Let me just. So the source is somewhere here. So it's 81 centimeters above the base of the cylinder. And from this part we measure the point, yeah, how much photons it releases. And then through the tables that you will write, it will turn them into, it will convert them into dose rate. So this is pretty much it till now. This is all I have because I didn't add anything else. The problem that might be, but I don't think there could be a big problem because we are going to present it and then she will just say, okay, this is wrong, this is wrong, this is wrong. It's that some of the data is not going to pass the statistical checks, you know?
Mm-hmm.
And that just, we have to deal with that, I guess.
Yeah. One more thing, can you again show me what the command was for the MCMP-v2 file, what the command was for how to run it? Because I can't really remember it anymore.
Oh, so
in the
for
command
the
window.
for the CMD, oh yes.
Yeah.
So you go to the command prompt, then you just write CD double points. This takes you back one folder, then CD again double points.
Okay, then to the MCMP folder.
And yeah, MCMP, I think it was 4C2.
Yeah.
No.
Oh wait, I can look it up.
I think I wrote it somewhere because I had problems with this. Just a second. I have it here. Just a second. You write CD in front. MCMP4C2. Yeah, it opens the folder. and then what you do is write mcmp.exe, and then you write an imp equals to example 15 minus example 15, and then you just enter it, and then it runs.
Okay.
Okay, so don't forget to write the CD. And also, what I had the problem with, the mcmp.exe was somehow deleted, so it couldn't find it, and so then I had to delete everything, copy some stuff, bring it back. So yeah, back and
God.
forth. So it took me like an hour to figure that out, but I figured it out. So just be careful on that. If it doesn't open, then check if your file is. So it's supposed to be, I think, this file. So
Yeah.
this file.
Got this.
Okay, so this is pretty much it. I don't think I have anything else to add except. Oops.
So let me summarize what we have to do. We
Yeah.
have to make some comments to the cell cards. So it's everyone has a little bit a different one.
Yeah.
Then we maybe change the coordinates for the surface card.
Mm-hmm.
Then we delete the command of mt1vtr02.
Okay, so about that, I will we will leave that. What I would so once I finish this, once I add the tables and everything, I will send the code again to you guys.
Okay.
So you can try fixing it, adding like other stuff. Like for example, here is RCC. You use something else or change. For example, instead of writing this on Y, write it on X or something like that. I don't know.
So yeah, maybe I will also just deliberately insert an error somewhere that she thinks I didn't copy it.
No, come on. It's fine even if you copy it completely because it's a presentation. I don't think she will say anything. She will not clearly. She will not remember everything. But like if you, for example, if you change from the Y, if you make it X, then it's everything is the same. You know, you don't have to change anything. So that you could change. And then this could literally stay the same. All of this. This part could change. This part, I mean, it shouldn't change. There is no reason to. Maybe you could change these numbers.
You can change the limit
19, right, 90, 91, 92, something like that.
Yeah, and you can also call it something like limit of the room or anything.
Exactly. And then what else could you change? So this can stay the same, no problem. Gamma, these from this part, I will correct it. It's wrong. Do not present this. I have to say. But other stuff, I think everything can stay the same. Maybe I used a certain type of stainless steel. Maybe you change some stuff. Like you can, if you write definition in MCMP of stainless steel, you can find a table. It shows all the different types of stainless steel. Like this one is, I think, stainless steel 301. So I only copied all these numbers. So I wrote the same numbers that were in the definition. So it's on Google. You can find all the materials that you want to define, and then you just use. And the stainless steel has like 30 materials. So I have 30 different stainless steels. So you can use this one. I don't mind. You can also use another one. It's not a problem. And this one, it's also lead. It's the same, no problem. Particle 2, the position, you just show the position where it is. So if you change X, then if you write this this on X, then you just write this on X too. So no problem. These are of course the same. Yeah, I guess this is pretty much it that I have till now. The other stuff I will probably add it tomorrow, or maybe I can try tonight, but I don't think so.
Yeah, no problem. Take your time.
And as I said, like once I finish these tables and everything, once I write the code correctly, I will just send it to you guys. Because what I'm planning to do is just one night before, I will just make the PowerPoint because it's also for the PowerPoint. I wanted to say this. Just go on the report that I sent you guys for the Monte Carlo and just use, basically you will just say the same stuff. So for example here, first case. So we decided defining the surfaces at the beginning, blah, blah. You say the same stuff. You just put this on the code and then, yeah, maybe a screenshot of the MCMP result from this. So you just explain it like I explained it in this report. It's nothing really important.
Did you send it in the group chat? Because I'm not sure, because for the last...
I CC'd you on the email. But
Yeah,
I sent
mail
it
it's there, but it not in
it
the-
was per mail, okay.
Yeah.
Let me check
So
it out.
yeah, you can do something like this. You can add the decay scheme of cesium 137. It's just as similar to this. Like it's no different. I've explained here everything. So, and then for the results, I also let me see here. I got the result last night without the photons. I mean without the neutrons. So. As you can see here, the neutrons is all zero because there are no neutrons. But I was stupid enough to think that there were. And yeah, then for the photons, I got some results here, I guess. Or yeah, here. So I got some results here for the photons. And all this other stuff, it's zero because she made us do it till 14 MeV. Which is no need because, as you know, from the file, from the source, we can only have like some amount of keV, I think, something like that. And then in the end, I don't think here is the, so I don't think we have here the dose rate, but if you guys don't mind, you can look into it because I don't really know where she explains it, where the doses are. I think I should listen to the video one more time just to know where the dose is. So this is the cell union total, and where is the dose here? There is nowhere. It's nowhere there. Yeah, this is for the neutrons. Detector located at. And then, yeah, so we need a result where we can see the detector located at. Let me see if it is anywhere here. Detector. Yeah, okay, yeah. So here. And this is the dose, and then you just do, you just use this one, the total. I think I solved it.
And we just run this file like 8 times because we have to use it for each detector, right?
Actually, you don't have to do that. What you can do is write it here. So just give a comment for the point, or so right here for P11. What was the point name? Yeah, for P11, you write it here P11. You give the coordinates of the you give the coordinates of these points, like P11. You give the coordinates and you write the table. Then you give the coordinates for the other point, and then you paste the table, you know?
So I just have to change the coordinates for the detector. Yeah, that's what I meant.
Yeah, instead of writing 35, you add here 45, right? And then you write the coordinates for the other detector. And then you 55 and then 65. And then in the results, you can, I removed the results. Yeah, so basically in the results, you will have the points. Like it will show you all the points. So you don't need to run it all over again, like 50 times. Just a second. So
Okay, we can
detector.
just put it into one.
So detector located at XY. So this shows where this detector is located, and the other detector is going to be here. So this detector is located here, and then it will show you the results. And then the other detector, it will say like, okay, this detector located here, and then it will show you. So you just use those results for each detector.
Okay.
Right.
Perfect.
Yeah. So you don't need to run the code 8 times. You just write the stuff 8 times, and then you just copy paste it 8 times. You just change this part, so the location of the detector.
Okay, great.
And also, by the way, I'm sorry, I think I explained this in wrongly. Just a second. Why can't I see my Zoom screen? Oh, okay. So these ones, this is X, Y, Z, as I said, and the R in the end, this is for how big the detector is. And since we have a point detector, we write
0.
R is 0. I'm sorry, this is not like the R, this is not R, this is Z. X, sorry. For me, this is X. So that's why I wrote here 41, because it's 41 centimeters away. So it's here. Okay?
Okay, yeah.
So this is 0 because point detector. It's going to be 0.
So the Y is the height, X is the distance, R is the radius.
Radius of the detector.
Okay, and the last 0 is these are only 4 values. Okay, I'm fine.
This is Z.
Yeah.
So when you do the detector in front, so wait, let me just open this. So when you do, for example, this detector here, down here, she didn't show it. So the detector down here, this is in front. So that means that Z is 41, and not on this side, X is 41. On this side, Z is minus 41, right?
Yeah.
Okay, so basically, let me just, I just want to be clearer. So here is our cylinder. Here in front of this, let's say it's the 1 point on the back. So this is Z. And on this side here, it's X. And on the back is minus Z. And on this side is minus X. Okay? Vishal, is everything fine?
Yep.
Okay, then I guess that was it. I don't have anything. If you guys have any questions, I will probably be doing this tomorrow, so I can just go on Zoom and then I can just slowly explain.
It's okay.
Otherwise, I think this is. It was quite easy when I found out that we only had to use photons. I thought that we had to use neutrons too, but apparently no need. It was only for the second example. So I guess we don't need to use neutrons, and we are basically from this point on is just simple.
Yeah, I also thought after I looked at the file that everything except the neutron part was quite clear.
Yeah. The neutron part is quite tricky. I mean, probably with newer versions of MCMP, it might be easy to work with them, but for this version, it's really difficult. It doesn't have a lot of cross sections. It doesn't, like, I don't know why it can't reach the cross sections. I have no idea. So, yeah, that was it.
So we are left with 3.5 minutes.
Yeah. We can discuss anything else.
No, I think we're good in a good time that we can stop.
Yeah, if you like, I know you tomorrow you have the. Actually, you don't have the exam tomorrow. Okay, so maybe you can just try, write this tomorrow, make the changes that I suggested you. Do not make a lot of changes, so you change your code.
Yeah.
If any one of you writes the tables, that would be amazing. Like checks the tables and writes them, that would be amazing because I wouldn't have to write them all by myself again. It's a pain
Yeah,
in the ass. believe
I
me.
would certainly look into it, but I'm not
Okay.
sure if I can get it 100% completely for the first one. But after that, I will be
Yeah, so-
able to write them.
Basically, just you can write either these ones here together with these, or these ones here together with these. So not a lot. Since we have 14 MeV, I guess you could use this one because you know it's our results is up to 14 MeV. So
Yeah.
maybe we don't even need to use that, but I will have to check one more time with Tuche and AJ.
Okay.
Actually, I need
Great.
another laptop to do this. So mostly after 12 only I'll ask my friend for the laptop and then only I can do it.
But oh, okay. Yeah, oh, that's really difficult with you, man.
That's
I mean,
complete.
everybody who has it's basically screwed. Who has a MacBook?
Maybe we can just you give us the input file that you changed with the comments and stuff, and we run it for you, and then we just send you the output file back.
Yeah, that could.
I'll
Yeah,
try
that
it.
could be a good way.
But first you finish finish your till like mine is on 18, so maybe on 14 I'll disturb you on Valentine's Day or maybe
Oh
on
yeah,
15.
yeah. That's good. I can. Okay, so if you want, we can do this. So I will. You can go on TeamViewer, and then you can use my laptop from TeamViewer to write the code by yourself.
I'll just change it somehow. I'll change it and send it to you. That will be much better because that way
Yeah.
it's good. This way it's good. Otherwise, I'll ask my friend for the laptop. Let's see.
Yeah. Okay. You also have time, so don't
Yeah,
worry about it.
that's the part. Like I have time. We'll discuss about it.
Yeah. If we have something wrong, we will tell you. Don't
Yeah,
worry.
yeah, yeah, yeah. Surely, like you should help. Like I don't have any idea of this particular subject.
So-
Not much.
Zoom closes down now.
Okay. Goodbye, guys. Talk
Bye.
to
I
you
wish you
tomorrow,
good evening.
everyone.
Okay.
Thank you. You
Okay,
too.
Andreas, I'll just try to send you the solution of fourth exercise, I guess. You can just send me like which one you were like, did you want to recheck it? Like I'll just
Okay.
solve.
Yeah, I will do that.
Yeah, that will be perfect. I don't have to read that text again like chats.
Yeah, no problem.
Then
Okay.
it's
Bye,
Have a
guys.
nice
Good night.
evening.
bye bye,
Bye.
Shabani. Good night.